Okay guys, so we're going to have a look at how we work out the structure of a repeating unit when we're asked to do this for a monomer turning into a polymer. And likewise we're going to have a look at how we would do the same if we were given the substructure of a polymer and turn it back into the original monomer. So let's take a generic monomer here, which is going to be from addition polymerization. So addition polymerization is when we add the monomers together, and this is where we use alkenes which have carbon-carbon double bonds. So your alkene that you're given will have a carbon-carbon double bond, and it will have groups on it. We'll call them A, B, D and E. And what you need to do is you need to take your molecule to find the double bond. What will happen whenever you carry out polymerization is you heat it with a catalyst, and what that does is it breaks the pi bond in the double bond. So that bond is broken, and if you look at the carbons there, you now have only 3 bonds. So what happens is each carbon is hungry for pairing up and getting a full outer shell, and it does so with other monomers that are around it, and in doing so you elongate the carbon chain until many tens of thousands of units and get a very long polymer unit. So how do we use that then to work out what the actual structure of this polymer would be? Well, we take our 2 carbons that were in the double bond, we'll call them X and Y here just for clarity's sake, and we take our groups that are around them, A, B, D and E, and if we can work out what all of those are, then we take our new bonds, which are the ones with the arrows on the end of it, okay, and we now have what's called a repeating unit for the polymer. If we were asked to draw 2 repeating units, all we would do is just double that up, nothing particularly complicated about it. Okay, so that would be 2 repeating units, and sometimes you're asked to do that. So let's have a look then at how we apply this to we'll take a really simple example like ethene. Okay, so there's ethene there. We're not getting any simpler than this. So we just apply it. We take our carbon X and Y. Okay, and we break one of the bonds in the double bond. And remember that new bonds will form either side. Oh, sorry about that. Okay, new bonds will form either side. We then put above and below, above and below. Okay. And we put, in this instance, all we have, oh, my pen's doing funny stuff here, are 4 hydrogens. Okay? So we should have 4 hydrogens up there, 2 in either one, and that is very simply our repeating unit for polythene. So let's do something that's maybe a little bit more complicated than polythene. So let's say the examiner says to us this time, you have got 2 methyl pent 2ene. Now my first piece of advice to you would be draw that out as you normally would. Put your double bond in position number 2, put your methyl on position number 2. Okay? And just put all your hydrogens in. Now, my next piece of advice would be to draw it, bring it down and draw it like I had on the last page. Take the double bond and put your groups at the 120-degree bond angles, and let's work out what the groups are. So let's take, we'll label our carbons X and Y again. Okay, well let's look at carbon X. We have here a CH3, so I just abbreviate that down to CH3 down here. I also have a CH3, so I would just do the same. On carbon Y, I have one too many hydrogens there. On carbon Y here, I have a hydrogen, so yep, I just do that. And then here on this carbon, I have a C2H5. Now, I know we've introduced an additional step, but it's better just to do this methodically and get it correct. Again, I take my carbon X and my carbon Y, okay, and I put my groups above and below, above and below. I put my new bonds there and there, and then I put that right there, and I look at what groups I had. CH3, H, CH3, C2, H5. Doesn't matter whether I put the CH3s, for example, here. It doesn't matter whether I put the H here or here. I can swap those 2 around. I just can't swap that with that, nor that with that. But I can put them, it doesn't matter whether they go above or below. Okay? And that's how you would get your repeating unit of that particular substance. Okay, so I'll do one last one here. Okay, so let's take X2E. Okay, and again, if I was you, I would draw it out. Straight chain, as you normally do. I would put my double bond in position number 2 and have my methyl group here and a methyl group here. I'll just label those X and Y for your sake. Don't do this in an exam, by the way, with the X's and the Y's. I'm just doing it to make life easy for you. Okay, let's find out what my groups are on my carbon X and my carbon Y. So carbon X has a CH3, I'll just put it above there. Okay, carbon X has a hydrogen here, so I will do that. I have a hydrogen there. Carbon Y has a CH3 here, and then it has this group here, okay, which is, if we start here, that is a CH, there's an H there, okay, with a branch CH3, and then at the end of it we have a C2H5. And then all I need to do in order to work out the repeating unit, I can take a little shortcut here. Okay, I get rid of one of the bonds in the double bond, just one of them. Okay, I put my new bond either side, and I do that. Okay, and that should be your repeating unit for your 3,4-dimethyl hex-2ene. Okay, so what if we're given then the polymer and we have to go back and work out the monomer? Well, that's really simple. What we do is, I'm just going to use the ones that I've already done here. Okay, we go and we find the carbons in the repeating unit that have got the bonds coming out of the square brackets or that are attached to the next carbons along, and we just pop back in our double bond, get rid of that bond there, get rid of that one there, and of course then that takes me back to my structure that I had above. I could go back to the one before here, and I would do exactly the same. It's getting a bit messy this, but if you get the picture, I would get rid of that. Once I've located my X and Y carbons, put my double bond back in, and there you go. That's the structure of your original alkane. And again, if they ask you to name that, you just go through your naming process like you've already been taught. Longest chain, okay, would be there, and then you would find your side groups if needs be. And the final one, which was ethane, but it's a bit messy. Let me just see if I can get rid of some of that, whatever happened up there. Okay. And I have hydrogen there, and I have hydrogen there. I would do exactly the same. I would get rid of the bond. I would get rid of this bond. Okay, and then I just simply pop in my double bond back into the structure there, and that was nice and easy to name. That would just be, of course, ethane. Okay, and that is how you convert monomers into polymers, and how you compare our polymer repeating units, and how you take your polymer repeating unit and bring it back to the original monomer. I hope that helps.